Welcome to today's webcast. I'm your host, Jim Fisher. I'd like to hand you over to our speaker today, David Heide. David, over to you.
Yes, hello. My name is David Heide. As you can see, I have over 30 years of experience coming today to talk to you about BIM 360 Field being used during startup and commissioning. I think back to the first project that I ever worked on a startup was back in the early 80s. It was a coal-fired plant in upstate New York, Somerset, New York. I was put on the 11 at night shift to 7 a.m. morning shift during startup to test out systems. So I would work with the plant operators and go out, turn a solenoid valve on, make sure that they get the indication back at the master control panel. At that time, the master control panel was about 20 feet long. You could walk in behind it. There were pilot lights all over the front. But we had detailed lists every night we had to go through and check out with the operators. Then the results of that test were handed in to the other engineers I worked with on the next day, and we would address any issues. What was interesting, from that control console, nowadays we have laptops or desktop computers and flat screen monitors, and everything's handled very simply and not as complicated as it was. What hasn't changed, though, is the need to have a plan and the need to have detailed checklists to determine how you were verifying things and what things were verified, what the status of those were, and being able to communicate that to other people involved. So if something needed to be corrected, it could be corrected and addressed. That way we were able to have a successful startup of the project. I've been working on several projects utilizing BIM 360 Field, and it's a great tool for that communication. A little bit about McCarthy. We're an employee-owned company. We've been around for 150 years. We have built over 55 water and wastewater treatment plants in the Southwest, over $1.5 billion worth of projects. We work in Arizona, which is our home of our Southwest division, California, Nevada, Colorado, New Mexico, and Texas.
Yes, ladies and gentlemen, here we have our first poll. You'll see it open up on your screen. Just click on your response and then select Submit.
While you're filling out that question, we'll proceed here. So the purpose of today's webinar is to talk about the need for detailed startup preparation and planning, and how important that is to start during the pre-construction phase of the project. We'll go on and talk about, on most projects, you have different areas, so how we phase in our startup processes, developing the detailed checklist that can range, we'll see in the next few slides, and how we have installation details, startup details. We go through everything so we can verify that inspectors, installers, everyone can know what we're doing. And we can also talk about the performance testing that's required for equipment. That's also very important to discuss during the pre-construction phase, as well as throughout the process. And the key there is communicating, making sure everyone knows what is required to be tested, how we are going to test it, and then reviewing the results of that test. Then all this leads to the successful startup of a plant. This is a project up in Denver, Colorado, Metropolitan Wastewater Reclamation District. It's one of the largest plants west of the Mississippi. This is a shot or excavation for the primary effluent pump station. Primary effluent pump station, blower building, 6 aeration basins, anoxic basins, and carb basins. This project increased the capacity of the overall plant by 100 million gallons a day. The key here is during this phase of the project, we need to start looking at how we are going to be testing and starting up this plant. Prior to installing any concrete during the design phase, we can determine if it's necessary, instead of having a plain end wall casting, to have a flanged wall casting that will allow us to add recirculation piping in. In addition, we may be able to add a couple of valves that will allow us to recirculate piping that will help us manage the use of water and startup of equipment prior to going into the actual process treatment. So this is an overall view of the entire plant. The photo that I just showed you is in the top left-hand corner to the right of the white building. Those are the aeration basins, blower building, primary effluent pump station. To the right of that, we're modifying 8 clarifiers installing new pumping stations. But while we're doing this, building this new, expanding the plant, we are integrating our work with existing plant where it is critical that they maintain their proper discharge permits and don't have any violations. So there's a lot of things going on. How do we start up this section of the plant without impacting the flow to the other plant? Here's the aeration basins at the Denver project. There's 6 aeration basins. There's over 4.5 million gallons of water in each aeration basin. So there's a lot of equipment here that we have to coordinate, check, so we don't waste water, so we're able to maximize the use of water and not have to handle it more than once or the minimum amount of times. This is our another project in Chandler, Arizona. It is a reclaimed water pump station, and there's over a dozen pumps there. We'll talk a little bit more about how difficult it is to start up this project. This was the 3rd phase of this project that we performed on the CMAR process. We were awarded all 3 projects. This pumping station associated with this area was a 40-foot excavation next to an existing operating facility. There's a 7.5 million gallon reservoir associated with this pumping station because the treated wastewater, the treated water, because it's not wastewater at the end, is then sent out for irrigation and other uses throughout Arizona to recharge the aquifer. Here's a project we have in 91st Avenue in Phoenix, Arizona. This project included 2 clarifiers that were 180-foot diameter, 2 new secondary clarifiers at 200-foot diameter, new aeration basins, odor control, and upgrades to the blower and chemical systems. It was a $105 million project that had to integrate existing or new systems into the existing process. There were over 100 separate maintenance of plant operations planning that were required to be tied before we could tie into the existing facility during the startup and construction of the project. So we have another poll question here. During startup and commissioning, what is the most challenging factor? And if you could click on which one's quantity of items to verify, coordination of contract documents, or schedule. So this area we're going to get into talking about the coordination of electrical, mechanical, and instrumentation drawings. In pre-construction, while these plans are being developed, we can help ensure that there's proper coordination, that equipment is tagged and identified on all the drawings so that we are able to properly have the proper power, startup, and testing of that equipment. Electrical drawings will show flow meters. So on there, we have to verify that we have the right conduit for power as well as control, and then it reflects the actual equipment that's being furnished. We have local control stations that we will need to verify startup of and verify remote control from SCADA. The mechanical drawings, as we all know, show the mechanical installations, the equipment, the flow meters, seal water requirements. So the mechanical drawings here, like I said, have seal water. So not only in our checklist we'll have, verification of the pressure gauges, we can identify that early during the design and the shop drawing approval so we can quantify that and verify during the equipment installation that we have the right materials in the right place, that we have proper seal water, lubrication, and controls for that equipment. The instrumentation drawings, a lot of time instrumentation drawings show things that pressure gauges or something that weren't shown on mechanical drawings. So we like to coordinate that so when we're doing our pipe takeoffs, we know where we need taps or connections for all our instrumentation. Make sure that all the items that are identified on the P&IDs are actually purchased and included in the list. Integrating all these and coordinating all these drawings as part of our startup plans helps us to understand what we're building, what's coming up, and the proper procedure for checkout and installation. Not only do we have all mechanical, electrical, and instrumentation drawings, we have the entire plant startup of integration. So we have different buildings. We could have chemical buildings, dewatering buildings, and aeration basins, secondary clarifiers. Ultimately, we can have up to numerous buildings. I'm going to use an example here, up to 24 buildings. So we have 24 buildings that we have to start up the coordination, and we have the communication amongst different people to verify that things are properly started up. In addition, if we just take one building, for example, the pumping stations, within that pumping station, we're going to have, possibly dozens of pumps, return activated sludge pumps, WAS pumps, sump pumps. All these different components have to be started up. So we need to identify what are the items for that. So as we're building, we had one project, we have 24 buildings. Now we have numerous pieces of equipment in each building. So for each piece of equipment, we technically have dozens of other items we're checking out, from installation, pre-grout inspections, alignment of the equipment, power to the equipment, then power test reports for starting up VFDs. Then we have performance testing. So everything is just multiplying and building onto each other. So what I was trying to summarize in the last few pictures, if we have 24 systems, we could have excess of 10,000 activities by the time we check out the physical equipment in the field into local stop-starts, remote stop-starts, I/O from that equipment. So we have all these activities. Then we have the number of people who need to be aware and who are contributing to the status of all this. For the contractor, we could have 10-plus people, depending on the size of the job, who are involved in checkout and startup of that equipment. Subcontractors and vendors, between electrical, instrumentation, and other subs, we could have another 25 people. The owner and the engineer's representatives, say we have a dozen people. In the past, we may have an Excel spreadsheet listing all the items where people go into that master book and check off that something's been completed. But that's really hard to communicate and distribute that information, get it out to everyone. So here's a question for you. What have we used on a project for record keeping and keep track of startup items? Have you used Excel spreadsheets, your memory, or other methods? As I was talking about before, we have all these items to check out for one piece of equipment. So this is a sample of just one portion of one spreadsheet for those 10,000 items. How do we verify them, and how do we accurately track them? How do we monitor the progress and make sure that we are going to meet our schedule? And all this, by checking all these boxes and verifying these things and making sure that they work properly, it will ultimately lead to a successful startup. So this is where BIM 360 Field comes into play. It is a web-based project software package that allows us not only to track startup and commissioning, but other items. As I mentioned, it's web-based. You can access it from your laptop, from your iPad. It provides pretty much instantaneous ability to track information, to carry around contract drawings, specifications, subsystems. It allows us to have all that ability to communicate it out to everyone. We can also generate reports, track items for accountability, so we can help drive the whole project team, engineers, owners, contractors, subcontractors to the successful completion. This is a short video with a little presentation for BIM 360 Field.
There are many different types of construction, but from large to small, from civil to commercial, to process and energy, they all share one thing in common. They are executed in the field on the job site. But there is a big problem in construction. According to CII, over 25 cents of every dollar spent is wasted in the field. One of the reasons for this inefficiency is that despite the fact that 75% of all construction dollars are spent in the field, technology is not being applied there. In fact, 90% of technology spend is in the office or trailer. Construction technology is built for the trailer or the office. It needs to be built for the field, where the work is done and the money is spent. This is where Autodesk BIM 360 Field comes in. Our field management software utilizes advances in mobile tablet technologies like the iPad and in online collaboration and reporting to revolutionize the way construction is done and managed in the field. Autodesk BIM 360 Field enables programs for quality, safety, commissioning, and bringing documents to the field, including building information models. Here's how. Project teams and managers can create field management programs in the Autodesk BIM 360 Field website, accessible from any computer with access to the Internet. It contains one place where all quality, safety, commissioning, punch listing, and other field issues are gathered and managed by area, responsible company, or any other way you like. You can manage your construction issues as well as checklists and build checklist libraries for reuse across projects. You can use the library feature to manage documents of any type, including building information models, and distribute them to project users in the office and in the field. Now let's go to the field, where the work gets done. You can then execute your programs in the field with Autodesk BIM 360 Field mobile application. Use the mobile app library feature to get field access and markup of plans and documents on the iPad. Also use the iPad app to execute your field quality, safety, and other programs. Even conduct punch lists. With Autodesk Field Management Solutions, you can even view models on the job site. You may or may not have cellular or other internet access on the job site. It doesn't matter. Autodesk BIM 360 Field works with or without it. In addition to iPads, Autodesk BIM 360 Field enables anyone with a BlackBerry or other email-compatible device to take pictures and email them into the website so that quality, safety, and any other to-do list items go into the master list on the website, where they are accessible to all job site participants. Then measure the progress of your project and your company programs using the Autodesk BIM 360 Field Reports and Dashboards. First, the Autodesk BIM 360 Field Reports take field information and instantly distribute it to others at the project for operations activities, like the tasking of issues or observations at the project level. Second, the reports and dashboards help management identify trends and measure performance of quality and safety programs across projects, trades, and teams.
So one of the interesting things about any tool, you need people to participate in it. On my last project, we put together the startup subsystem plans, which included a narrative, included all the checklists that we will be looking into a little more here, recirculation plans for how we were going to test the equipment, performance requirements. So we had a narrative. The engineer or the inspector on the last job wanted a hard copy of that, and he wanted a hard copy of the checklist. It took a while to get him from his side of the fence, the way he was looking at it, because he hadn't been exposed to this before, to sit down with him and demonstrate the benefits of using a system like this. Ultimately, he got so where he was looking over the stone wall, and then he got to the point where he was standing up on the stone wall. Then he jumped in full force utilizing this. We used it for startup. We used it for punch list or work to complete items, and it was a great tool. And ultimately, it was a great way to communicate where we stood on the results. So this page here we have, each project is set up their own web address, as it said in the presentation there. So if you're out in the field, you can actually take a picture of an issue if you're, and whoever, if it's a punch list item or work to complete, you can actually pin that to a drawing so you know the location, and you can create an issue when you come back in the office so you can track that issue and move forward. So on the left-hand side of the page, you have issues, which a lot of times we think of issues are problems. Issues are tasks, or they can be quality items in the field. So we will be able to click down and see all the issues. We have checklists that we can create. We can create checklists for pre-pour placements. So the contractor as well as the engineer can go off and sign electronically on a pre-pour card. Sorry about that tongue twist. There's also a photo library where you can attach photos and tag them to specific locations, as well as the ability to generate reports. And that's really a great thing to have because you can see the overall status. You can break it down by area, by system, by subcontractor or vendor, and identify and help them sit down and talk about issues or things that have to be done. In the center of this page, the tan represents the quantity of issues or tasks that have been inputted in BIM 360. And you can see they sort of came before the blue lines. The blue lines were as they were closed out, acknowledged and approved and resolved. So here's one example of one item. So we have the Westraz pump station. So when you set up your startup and commissioning checklist, you have your overall project, then you break it down to your subsystems, which this one is the Westraz pump station, and then you can break it down to each individual pump. And on this one pump, you can see in the parentheses, we had 24 issues or 24 items to check off. That would include power available, recirculation plan in place so we could check it, manufacturer certificate of proper installation, and on, performance testing. So if we look at the first item on the top that says RAS Pump 3, ORT 2 for DP1. So that's basically an operational readiness testing. On the specific project, it was a requirement that the owner had different levels of these testing to do for the Profibus communications. One was just checking out the wires and then checking out after the instruments were connected and then checking out the signals after all that was done. There were different levels. So you could see on the bottom, the first item was put by the owner integrator. He said the flow meter is accessible from the computer. The next item up, the electrical inspector noted that there was a potential problem. And then we could distribute that to our vendor or subs saying, see comments, here's a list of items you have to resolve. And then ultimately, I could come back and we could change it to not approved, needing follow-up. It would come back with a response from the vendor or subcontractor, and we would change the status to work complete. And then the engineer would get a report once a week of all the items that could be verified. And then he would show that it was acknowledged, and ultimately we could go in and close that item out. And we could track where we stood all the way through the project. This is just a continuation of some other samples. I talked about the MCOPI and how it was submitted, and then we also had SureTrack that we were tracking things in there too. So the engineer came back and said, well, once it's approved there, we'll sign it off here. And the next item was a performance testing, a 2-hour performance testing of the pump. By clearly delineating all the tasks, and you could verify that you were making progress towards the startup of the project. This report is hard to read. I don't expect you to read, but you could print one up for the whole job with every location and sub-location. What's interesting is when this overall report is printed, you could see that, as the startup was going, it went from the motor control to electrical rooms. You could see that things were reaching 100% sign-off and approval for VFDs, for switchgear, for panel boards. Then we could go out and see the next activities where it was associated with, is the local control panel wired? Is the pump motor wired? Have they been measured? And you just see the progression of items moving to 100% complete that allows you to start doing the mechanical checkout with the actual manufacturer, bumping the motor, starting to pump fluid to verify the operation of the pump. It's a great way to communicate the status of the project to everyone involved on the project, as well as the people who are back in our main offices, our bosses and people we have to report to, so they know where we stand overall on the project. On this one project, I think there were 6,800 items, and we had it was basically ball and court. So they were all open items initially when creating the list. And then as the contractor, McCarthy, or subcontractors finished items, we would move the status to work complete. That would then signal us to send a report to the inspectors or engineers that they had these items available to verify. A lot of times they were out there in the field verifying the actual operation when we were checking out initially, but they could go in and they could see how many items they had in their court that they had needed to go in to acknowledge. Once they acknowledged it, we could move that item to work or closed. Or if they had a concern that the paperwork that was attached to a specific item, we'll get to that in a minute, they could say, ask for additional information. So we can move the status to not approved or needing additional information. So this is going back to the issue tab on the left-hand side. Each issue has a detailed explanation of what it was, the task was, as well as the location. So this was Westraz Pump Station, pump number 3. You can see it highlighted in the bottom right-hand corner there. The little cloud means that there was a comment attached to it, whether somebody said a work was completed or if they said it was acknowledged. The little paperclip means that there was an attachment. You're able to attach test documents, photos to the activity. So as I mentioned, on the top right here, when you click on that issue item, you have the details, the description of the task. You have the page which is showing up. Oh, somehow I missed the slide. So this is actually an attachment to the slide, which is a test report from a third-party testing company that came out to actually test the motor. So when the engineer goes to review that this item is complete, because he's not out there witnessing every single test, he can pull up the documentation and verify that it meets the requirements of the contract documents. Next, please. And here it shows the comments that are added. What I really like about it is when you add a comment, it puts your email as your signature and the time you added it. So you can track and see who actually commented, who changed the status to approved or closed. So it's very helpful to go back, and if you needed to go back, if something was signed off by mistake, you could always go back and open it up, put a comment in it, and change the status and follow up on that item. Next slide, please. In addition to being able to add attachments to each item, BIM 360 Field has a library set up. This was useful because we could take all those subsystem startup packages and you could actually save them into a folder in this library. So if you had your iPad or if you were at your desk and you wanted to reference a startup package, you could just click on it and open up. We also set up folders for our instrumentation subcontractor who would have his calibration report. So he would have a weekly spreadsheet with all the instruments, different types of instruments. So everyone could go in and see what the status was, because we may not have all the test reports and calibration reports available. So you can look and see what the status was, and you can go check up with his hard copies that would ultimately be turned over at the end of the project. We also did this for measuring. There were thousands, tens of thousands of cables that had to be measured. So we had a master log that we updated in the library weekly. And the electrical engineer could go in and say, yep, things are getting measured. He could also go over to the electrical subcontractor's trailer and audit the actual copies of the paperwork that were ultimately going to be turned over in PDF form at the end of the job. So you could go to the library, select the folder, select the specific spreadsheet you want to look at, and open up and view what were the contents of that spreadsheet. And there's one of the attachments that's actually from the owner's integrator SCADA people. So why would you want to use this on your project? I think it provides great communication between all parties, being able to facilitate timely startup, higher quality. You're able to make sure that all the things are checked out and verified and that people have bought into it. It reduces redundancy where people have say, I don't remember signing that off. You can actually go in and see where they acknowledged that something was tested. It actually helps eliminate issues. And that goes back not just to BIM, but it goes back to the early planning for startup during the pre-construction period. Identifying what you're testing, what you're installing, how you're testing it, how your test loops, your recirculation loops will be in place, and what tests are required. You get all that information out in front of everyone, it makes it a lot easier and much more thorough. You can also manage it, communicate the information, because everyone can't know everything, but it's an easy means to communicate that information. And you can see at the end that every box is checked, every item has thoroughly been checked off, and ultimately, the last job, that Denver project, it led to a very anticlimactic startup. I remember when we finally put flow in through the process, everything went very smoothly. It was almost a little letdown as a startup person. I mean, you don't want things to go bad, but it was all that hard work that you put into the job and planning, and see it come to fruition ultimately was a great feeling.
Thanks, David. That was a great presentation. Okay, it looks like we've got a few questions come through here.
Okay.
Well, let's get to the first question. What's the cost to my project?
The cost is determined by the specific size of the project. It varies on the size of the project, but ultimately the savings that you incur, I would say, take care of the actual cost. It's a portion of a percent attributed based on the size of the project. But like I said, you're able to actually eliminate or maximize the use of the people you have on the job by being more efficient and being able to communicate that, be less redundant on verification of things, and it ultimately is a cost savings.
Okay, we've got another question here. What information do I get after the project?
At the end of the project, you get a copy of all the checklists, the file attachments, the records can all be transmitted to you in PDF form. So you basically get all the data that has been collected.
Okay. And we've got another one here. How many people can access BIM 360 Field?
That's a good question, Jim. McCarthy's license with Autodesk is that we have unlimited access. So or however many people are on the project, whether it's engineers, owners, contractor, personnel, or subcontractors, we have access to add people on.
Besides startup, what else can BIM 360 Field be used for?
As I pointed out during the video and some of the other portions, it's very useful for as you're walking in the field. If you need to identify an issue during construction, if you see something, you can take a picture of it. So work to complete items, it's very useful for communicating where something is. A lot of times you can write something down or you can tell someone something, but it's a great tool and a great communicator to be able to take a picture of it and be able to put that in the BIM 360 Field. You create an issue, you can link it to an area, a certain floor, a certain room, a certain piece of equipment, and you can assign it to a responsible party, and then you can actually follow up on that. And you can sit down with a report that actually has a picture in the description, so it can be used for work to complete, punch list activities, pre-pour, pre-placement inspections. I also created checklists for, like, during the construction of the aeration basins, you could go in and create a checklist, and you could use that checklist for all 6 aeration basins and update the status of construction, make sure that the ladder stops are installed at the bottom of the aeration basins or that things are painted, and you can just help assist during construction and identify items.
Another one here. How do I get training?
On each job, McCarthy has a BIM 360 portion of our IT department for the detailed training. And so the project team will set up. Most of us have gone through that initial training, and I've been able, on my job, since I've been able to learn it, I think pretty much anyone can. I just trained on the project I'm on, a couple of the owners, SCADA persons. It's very easy to learn as a tool, and I think some of the stuff, there is a lot of preparation in developing the checklist, but as far as a user in the field, it's very easy, and we can provide hands-on training in the field.
Okay, this question sort of comes alongside this one, Dave. And how long does it take to become familiar with the tool, and what experience do we need to have to run the tool?
I think if you can click a mouse and open up an internet page, it's pretty darn easy. Using the tool, the people I showed yesterday, I probably spent 15, 20 minutes. What they were going to do is go into a specific I/O issues or tasks and add a comment, whether they verified it. So depending on to what extent, if you're creating checklists, that would take a little longer, but we would work, and help develop those on a job. It's very easy to learn. The initial training that we received was, I think, 2 4-hour classes, but that was for like the administrator on each project and not necessarily the end user. I'd say half hour, an hour, if that long, you could probably learn to use the checklist portion and the issue portion.
Great. Okay, so we're running out of time here. What we want to do is wrap up today's session Watch your inbox for directions. We're going to be sending you an email with the link to get access to the presentation and the recording. Here's David's contact details. If you've got any further questions or would like anything in addition to that, please contact David. If we haven't answered all your questions today, we'll endeavour to get a response back to you as soon as we can. And in closing this webcast, I'd like to thank David for all the work that you've done on the presentation, and I'd like to thank you all also for joining the webcast. It's been a pleasure, and we hope to see you at another McCarthy Learning opportunity soon.